Well, good morning, everyone. Welcome to the 2020 Better Buildings, Better Plants Summit, our virtual leadership symposium today. I want to thank everyone for being with us today, including speakers and attendees. This is going to be our second Best of the Better section, in which we are going to recognize this year's awardees of the Better Project and Practice Awards. We had a great number of excellent applications, and now we're going to have some excellent presentations from some of the best energy management professionals in the country, as well as in North America, as we have one from Quebec, who I will introduce in just a few moments. Before we dive in, I just want to cover a couple housekeeping points. Please note that today's session is being recorded and will be archived on the Better Building Solutions Center. We will follow up when today's recording and slides are made available. Next, attendees are all in listen-only mode, so your microphones are muted. If you experience any audio or visual issues during today's session, please send a message in your chat window located at the bottom of your Zoom panel. I'd like to welcome you again. My name is Bruce Lung, and I'll be your moderator for today. We have a lot of presentations going on, so we're going to start at a pretty good clip and hopefully finish within the time limits. The agenda today is that we're going to have some opening remarks from our director at the Advanced Manufacturing Office, Ms. Valerie Leitner, and then we'll dive right into the presentations for the speakers. I'd like to bring on our colleague, Eli Levine, the program manager for Better Plants, who will perform an introduction for Ms. Valerie Leitner. Eli?
Hey, thanks, Bruce, and thanks, everyone. I'll echo what Bruce said, that this was a very challenging competition. We've received more applications than we've ever received before, and we're really just blown away by the level of all the great work that you guys are doing. So I'll keep this short and sweet, but it's my honor to introduce Valerie Leitner, who Valerie leads our Advanced Manufacturing Office. She's been with the federal government in various capacities for 35 years now. Prior to being with the Advanced Manufacturing Office, she served in the Loan Programs Office and was worked in the Bioenergy Office as well. She has a background in chemical engineering. So with that, Valerie, thank you for joining us in your leadership running AMO.
Hey, thanks, Eli. So I want to welcome everyone to this session and to congratulate the award winners. Like Eli said, there was a lot of competition this year, and we were just really excited that so many of you submitted applications to the award process. And I want to thank Eli and Bruce and Cliff for organizing this session and also for organizing the whole award process. So I really look forward to hearing from you guys on some of your great achievements. To kick off the session, I thought I would just start off by giving a little context of AMO, just reminding you of how you fit in as Better Plants partners. And then also give you some, I guess, ideas of the way maybe you can expand your partnership by partnering either with the national labs or through some of the other opportunities that we have in AMO that are in addition to being Better Plants partners. So,
slide.
Yeah, thank you. So do I just say next slide or do I have?
That's correct.
All right, so I know you're all familiar with the role of AMO, and our mission space is to catalyze research, development, and adoption of advanced manufacturing technologies. And where you fit in as Better Plants partners is that adoption piece, and specifically focused on energy management. And with the manufacturing sector comprising 25% of the nation's energy use, you partnering with us to establish and meet goals to reduce your energy intensity by 25% over 10 years is a really impactful in the energy space in the United States. Eli and his team have continued to work with you and to look for opportunities to expand your partnership with you. And some of the things that they've done recently is expanding to include water and wastewater treatment facilities, and also offering opportunities to partner with our national labs, such as the National Lab Technology Days, and then also starting pilots like the waste reduction pilot that was started this year. And it's something that we plan, I think Eli mentioned this on Monday, to kick off later this summer is another pilot on field validation. And in field validation, we're really looking for Better Plants partners to be first adopters of some of the technologies that have been developed in AMO or have been developed by our energy management partners. So next slide. So in our next slides, I'm going to focus on some of the recent work that we've been focused on in AMO and give you some examples of ways that you can engage in partnerships with us. And with COVID being on everyone's mind, I thought that I would just share some examples of some of the work that the national labs are doing, taking advantage of partnerships that they have developed with industry through programs like AMO. And then being able to use that relationship to assist industry in rapidly changing their manufacturing where they have capabilities to make. And in this particular case, it's some of the medical supplies that have been in such short supply as the COVID ramped up. So particularly they're focused on making masks, ventilators, and consumables. So next slide. So taking advantage of some of the capabilities at the manufacturing demonstration facility, which focuses on additive manufacturing, Oak Ridge has used their metal manufacturing capability to make injection molding tubing for parts such as collection tubes for test kits. So what they've done is shared the designs for the injection molding tooling on an open source platform. And they've shared it particularly with certain companies they're already working with, but then they wanted to make that available to any company that might have injection molding capabilities so that they could also help support making some of these needed test kit supplies such as test tubes. Another example of something that Oak Ridge did was recognizing that the freeforms for soda bottles that Coca-Cola makes looked a lot like test tubes. They reached out to them and connected them with some laboratories that could test their preforms for use in the test kits, and it turns out that they worked great. And so as of last week, Coca-Cola issued a press release saying that they had already made 7 million of the tubes and provided them for test kits. Next slide. Another example of some of the work that we're doing with industry for COVID is related to our carbon fiber technology facility. And here, it's an interesting story where the inventor of the N95 mask actually recently retired from the University of Tennessee. And he ended up partnering with the CFTF to develop a melt-blown process to make N95 materials. And so it's first melt blown, and then there's an electrostatic charging that occurs to make the material active in preventing the transmission of the virus. So Oak Ridge has been working with him and has partnered with Cummins to then transition this technology to Cummins, who has melt blowing capabilities, and they can produce millions of pounds of the N95 material. And again, in this case, they're open sourcing the technology and looking to partner with other companies that also have the melt blown capabilities that can make the N95 materials. Next slide. And in the past year or so, the Department of Energy has announced 3 grand challenges, one related to energy storage, one on plastics innovation, and one on water security. And the Advanced Manufacturing Office is working in all of these areas. And in the energy storage area, there have been remote workshops like the one we're having now over the last month or two to gather information from stakeholders to inform a draft roadmap that'll be issued later this summer. And along with the roadmap, there will also be a request for information. So for folks that weren't able to join the webinars, an opportunity to weigh in on where you feel the right federal role is for energy storage. AMO has been partnering with the Vehicle Technologies program. Last year, we had a topic in our funding opportunity to use manufacturing, battery manufacturing, to help drive down the cost of battery energy storage materials systems for vehicle applications. And just a couple weeks ago, we released a joint lab call with Vehicle Technologies, looking for industry to partner with the national labs through CRADAs to use the national lab capabilities to help scale some of their energy storage systems. So look for some additional information coming out about how you might partner with the national labs on that. The applications are due July 17th. Also under the Plastics Innovation Challenge, this was issued to address the issue of waste plastics getting in the oceans and in our landfills. And what the Plastics Innovation Challenge is looking to do is both develop technologies that can make plastics that are recyclable by design, and also help the value proposition for dealing with that waste plastic that's already in our landfills. So making value-added products out of the waste that's currently in landfills and oceans. And then the third grand challenge area is underwater security. And last September, AMO announced the selection of the National Alliance for Water Innovation to lead a energy innovation hub to produce type parity water from non-traditional sources. So that team has recently started a series of roadmaps to inform, what work should be done under the hub. They are open for additional members. So, if you're interested in that area, just look for those opportunities to join. They're open for membership. And then the other thing that we're working on in the water area that may be of interest is that in our fiscal year 20 appropriation, we received $20 million for efficient water and wastewater research and development, and we plan to issue a funding opportunity soon on that. So next slide. And this is my last slide, just an example again that I wanted to share with you about the high performance computing for manufacturing program. And this is a program where we seek to use the capabilities, the high performance computing capabilities at the national lab to solve industry challenges. And if you're not familiar with this program, we have 2 calls a year. The funding does go to the national labs. It's about $300K for them to use their computing resources to solve some of your challenges. And this example that I have here is from a partnership between Lawrence Livermore and Vitro Glass. And what they did is they used the high performance computing capacity to develop a fast running machine learning algorithm that can be used on a laptop computer. And so typically when they're trying to optimize their melt furnaces, it could take up to a couple of weeks. And with this machine learning algorithm, they can now do that real time and make adjustments in their furnace. So this is just one example of how industry has used that capability to optimize their process. So next slide. I just wanted to throw up a few of these examples just to encourage you to continue to work with Eli and the team to explore some of these opportunities to expand your partnership with the Advanced Manufacturing Office. And I look forward to hearing about the successes that made you award winners. So thank you.
Well, thank you very much, Valerie. I'd like to go back real quick and do one last bit of housekeeping. As you may know, we are working with Slido this year. And Clifton, if you can go back real quick, just let everybody know about the Slido slides. Basically, if you can just go to www.slido.com, either on your computer or a mobile device, and open a window in your browser. If you can plug in the code for today's event, it's that symbol is BB Summit, so BBSUMMIT. Once you enter this event code, then you'll see a menu, a drop-down menu, and you want to select the best of the betters. This is how we will have questions and comments for our panelists. So if you have any questions, you can submit them anytime in this presentation, and we'll be answering them at the end of the session. In addition, you can select the thumbs up icon and upvote some of the questions or comments that you like, and this will kind of move them up to the top of the queue, so we'll know they're important to a lot of the attendees. I'd like to just take a quick moment for everyone to open up Slido and be able to select our session. Okay, hopefully everyone is there. Hey, Clifton, can you include the Slido info in the chat for everyone? Okay. Hopefully by now everyone's been able to get onto Slido. If you can advance the slides, Clifton, we're going to jump into our first. And also be advised, we are using social media. So this is the Twitter and LinkedIn links for the Better Buildings, Better Plants and the summit. I'd like to introduce our panelists, starting with the first one. In the interest of time, we will not be reading all the bios, but they will be available with the conference materials on our website. Please bear in mind, each speaker will have 6 minutes. Our first speakers today are from Electrolux, Mike Brown and Daniel Lefebvre. Mike Brown is a manufacturing engineering manager, and Daniel Lefebvre is a project manager for North America Green Spirit Leader. Electrolux was a project awardee for an innovative sphagnum moss water efficiency project. So Mike and Daniel, please go ahead.
Yeah, thanks Bruce. Hello everybody, I'm Daniel Lefebvre, project manager at Electrolux. So thanks to the DOE Better Plan program for this recognition. This project that my colleague Mike Brown will cover in a few seconds is a typical example of project that we are doing at Electrolux to contribute to our sustainability strategy for the Better 2030. Can you change the slide, please? Yep, thank you. So this innovation support two of our promise to be climate neutral and drive clean and resource efficient operation and elimination of harmful material. I will let Mike, our ME director of our Kinston, North Carolina dishwasher facility, explain this water treatment solution. So thanks again to DOE. Mike?
Yeah, next slide, please. Again, my name is Mike Brown. I'm the manufacturing engineering manager for Electrolux Home Products, Kinston, North Carolina dishwasher facility. Our project involved the implementation of sphagnum moss that took the place of the hazardous chemicals that are historically or typically used in treating processed water, such as cooling towers, chilling water loops, quench tanks. The specific species of sphagnum moss that is used in this system promotes the breakdown of scale and other contaminants, and it has special properties that enables this to happen. And it gives us better results with better operating efficiencies. So it's better, and it's also a very environmentally favorable solution. If you look at the bottom left picture, you'll see the moss is provided or created in either bags or coupons. One of the challenges that the team worked on is to provide sufficient contact time, water contact time with the processed water for the moss to do its work. And we went through all the operations in the factory, and we are now 100% converted over to moss, and we have sustained it since 2017. So sphagnum moss, it provides Electrolux with a sustainable biological wastewater treatment technology that has improved water efficiency, energy efficiency, and better water quality and odor and so forth. Next, please, slide. Okay, so you see the water savings, energy savings, next. And then, as we say, it improves, it's less maintenance because with the reduction in scale, for instance, in our towers, we now do not have to clean periodically. The towers essentially stay clean with little or no maintenance needed. And the material is actually reusable, recyclable as mulch or no absorbent. It's got a 10-time ratio on absorbency. Next slide. The picture to the left shows the inside of the plastic tower for our plastics injection molding operation. That's before moss implementation. And you look at the picture in the middle. This is after implementation, and you can see a dramatic difference in the clarity of the water and scale buildup. And then if you carry to the right picture, you'll see present day. We have sustained that same cleanliness. In fact, it's continued to get cleaner as we use moss. That's the one characteristic of this project. The longer you use it, the better the water characteristics are. The information on the bottom shows the plastic water loop, molybdenum, iron conductivity, and microbiological contamination before the testing or before our conversion. And then after conversion, you can see dramatic improvements in every area, every category. Specifically, we were going after improving the conductivity and the molybdenum. And then the recent test, you can see the analysis of May of this year. We have continued to improve, and you see all the numbers are getting steadily better over time. So we have to demonstrate this. This will absolutely prove that it is a very sustainable project. Next slide, please. One of the key KPIs that we have on Green Spirit, our Green Spirit program, is water reduction year-over-year targets. Thanks to sphagnum moss, we were able to achieve the goal of, we actually had a 5.6 year-over-year reduction from 2017 to 2018, and moss was a big part of that. So in addition to having a cleaner process that's more manageable maintenance-wise, we also had a very good water savings program.
The 6-minute mark. If you were just going to finish it up, that would be helpful.
I'm finished.
Okay, great. Well, thank you very much. That was a great presentation. Next, I'd like to introduce Ms. Amy Costello from Armstrong Flooring. Armstrong Flooring was a Better Practice awardee this year for a 0 kilowatt challenge that enabled them to shut off a lot of unneeded applications. Amy is a sustainability manager for Armstrong Flooring. And with that, I'll let Amy take it away.
Awesome, thank you. Armstrong Flooring is honored to have been selected as a best practice winner. Our best practice submission was actually entitled 0 Kilowatt Challenge, and the goal of this challenge was to reduce energy by updating our planned shutdown procedures. And so what we mean by a planned shutdown procedure, it's just when the plants have been intentionally brought down, so when we're not operating our production lines. You can change the slide. And so what we want to do is reduce the energy when our plants were shut down. And we also wanted to benchmark our process because we really didn't understand as a company what should the amount of energy be for our plants when they were shut down. So what we did is we asked our plants to simply update their procedures, their planned shutdown procedures when the plant was not running to reduce the energy to the extent possible. And so they systematically went through and they looked for the opportunities to reduce energy. And we titled it a 0 Kilowatt Challenge, even though we knew that we would not be able to get to 0 kilowatts, because when our plants are shut down, we still have maintenance crews that are in the plants that are working in the plants. But we really wanted the plants to be able to go as low as possible. And so we started off with some really simple, easy things, changes that they made to their shutdown procedures, things as simple as including in our shutdown procedures a map of where the light switches were located so that anybody who was new to the company would know how and where to turn off our lights. We progressed into adding sensors so that the lights would go on and off automatically, so that was not an issue. But the real effort where we got one of the biggest impact was really analyzing the equipment that was running in the plant during our planned shutdown procedures and really trying to determine how we could turn the pieces of equipment that were running, turn those off on the weekends and during the planned shutdown. So for example, we had our compressors. We were running our compressors at our Lancaster, Pennsylvania plant, which is the plant we started doing our challenge with. And we were running our compressors over the weekends, and we were running them because we had to maintain the fire suppression system. But what we realized is we didn't need to run both compressors to maintain the fire suppression system. So we were able to bring down one compressor and still be able to run our fire suppression system with the other compressor. And so our maintenance manager was able to look at how much energy we were using at the plant. We used our demand management system, so it's real-time data. He could go in, he could turn off equipment, look at our demand management online system and see how that was impacting our energy. And that really led to our key performance metric, and that was kilowatts used during plant shutdown. So we basically looked at how many kilowatts we were using at 11 p.m. on a Saturday when the plant was shut down. And we did this before we started studying and making changes to our shutdown procedures. And then we did this after we made changes. You're using about 800 kilowatts at 11 p.m. on Saturday. And on average, there were fluctuations that would go up and down, but kind of as a mean, it was about 800 kilowatts. And as we went through this process, we could watch it's almost like a stair step of watching our kilowatts go down Saturday after Saturday as we implemented new things to further reduce energy. And by the time we were finished, we had gotten down to 350 kilowatts was kind of the lowest that we were able to bring the plant, but on average, we provide Monday for plant staff to really look for these opportunities to further reduce their energy. And so what the was really that you need to establish and review your shutdown procedures at least annually. And probably more, and what we are doing is we were not doing before is when we have, our engineering, our capital engineering, when we have large projects, when we close out those projects, the last step in that phase is to really go back and update the shutdown procedures. So as we put in new lines, new equipment, we were not updating our shutdown procedures on a regular cadence. And I think that's really important if you're not doing that to look at how, when were your shutdown procedures last updated. Also regularly monitor, track, and share the energy use during shutdown. We shared it with our plants in-house. We shared it with the team what we were doing. But we also learned there was a lot of value in sharing between our plants. So with not just the Lancaster plant, but with our other plants, as they learned how to do things such as bring down, turn off the chillers, and the learning that was involved in figuring out how to do that, transferring that knowledge to our other plants so they could also take advantage of that situation as well. And then the last piece that I'll share is really understanding the energy use data as a diagnostic. I mentioned that we shut down our compressors. We learned that our compressors would actually turn on every 6 hours to maintain our fire suppression system. And then December of last year, our maintenance manager noticed that our compressors were now turning on every 5 hours. And then at the beginning of this year, our compressors were coming on every 3 hours. And we were actually able to diagnose a water leak because we were monitoring our shutdown procedures. And I thought this was really cool that we were able to use our shutdown energy and the fact that we were monitoring it so closely to identify a water leak before it even showed up on our water bill or there was any sign of a water leak within our facility. Also, as a procurement tool, one of the things that we've learned as we've gone through this process is that some of our equipment we cannot shut down. And we've talked to our equipment suppliers, and they've said, no, absolutely, you cannot bring this piece of equipment down because it cause damage and you'll permanently cause problems with the equipment. And so that's really led us to think about, as we look at new technologies, to ask the question up front when we're thinking about different technologies and different equipment, is to ask, how do you shut this piece of equipment down? Can it be brought down? And use that as maybe a part of the selection process as you're looking at equipment to use in your facility. So again,
thanks, Amy. I think we're just
selected for the best practice challenge, and hopefully you've gained something from this presentation. Thank you.
Great. Thank you very much, Amy. Next, I'd like to present the Ford Motor Company, Jeff White, who is the Energy Manager for Global Utility Supply and Efficiency. Ford Motor won a Better Project Award for redesigning their plant and including CHP in the new plant's redesign. There's also a lot of other innovative things, and I'll let Jeff go ahead and tell us all about it. Go ahead, Jeff.
Thank you to the DOE team for hosting this conference, inviting me to speak on Ford's behalf about this new central energy plant. Next slide. Yeah, next slide. The who, what, when, where, why, and how of this project is a remarkable story of vision, collaboration, and cooperation to deliver a state-of-the-art energy center that will function as the heartbeat of Ford's research and engineering center in Dearborn, Michigan. Next slide. The companies listed on this screen cooperated to do an amazing construction feats, such as putting up these tilt-up precast walls for a 100,000 square foot, 2-story building in 1 week, putting a 5 million gallon tank up in 2 weeks, building everything on skids to minimize congestion on site, prefabrication of pipes and structures to minimize on-site welds and labor. For example, more than 80% of the piping installed on this project was shop fabricated to minimize field welding. Next slide. This project began with a vision of a new modern campus to attract and house the next generation of Ford's employees in Dearborn, Michigan. Next slide. The utilities serving the campus were old, failing, and inadequate. So a new 200 PSI gas surface to power the plant and consolidation of 6 different electrical feeds into 2 120 kV services ensures energy reliability for the foreseeable future for this campus. Next slide. For those of you who don't know, the Ford campus is in Michigan. Next slide. All of the necessary utilities to heat, cool, and power up the new campus were considered in the development of this project. We said goodbye to the old Albert Kahn designed steam plant to welcome the addition of a new modern central plant. Next slide. Beginning in 2016 and concluding with the certificate of occupancy and commencement of commercial operations in December 31st of 2019. Next slide. N+1 utility resilience and environmental impact of this facility were 2 of the key design requirements that drove a recursive co-design process intended to ensure risk mitigation and cost controls. Next slide. There were many questions as to how this project would come together. Next slide. And this slide represents a sample of how those questions drove the thought process, the selection of the partners, and the ultimate design as an ahead of the meter facility. Next slide. The contractual relationships that were developed between private, regulated, and non-regulated entities is unique and serves as a model for how this country can solve regional and local utility infrastructure needs and improvements. Next slide. For example, the regulated utility owns the gas turbines and heat recovery boilers. The output of those assets are sold to Ford at tariff rates. The balance of plant and the building itself are owned and operated by the unregulated affiliate. The output of those assets are owned by Ford, and the ownership of the assets themselves transfer to Ford at the end of term. Next slide. I've included some pictures of key systems, but 6 minutes is woefully inadequate to cover the amazing team effort that went into the design, construction, and commissioning of this facility. Next slide. While scrolling through the remaining pictures, I will talk about the digital twin aspects of this project. Next slide. The entire project was developed as a 3D model. The model dictated where every pipe hanger, every fire suppression head, next slide, every conduit, cable tray, and pipe should be located in 3D space. Technology was used to mark precisely where each and every pipe hanger should be located. Each one was installed before any pipe was delivered to the site. Next slide. The pipes were numbered and lifted into place, and then technology was used to validate the actual installation and ensure alignment with the 3D model. Next slide. Systems such as the thermal storage tank were used to model stratification design for the chilled water supply and return to the campus. Next slide. Pipe fitters had several on-site computer displays to reference the 3D model as needed. Next slide. The 3D model was then further enhanced into a digital twin that contained specifications and operating parameters, next slide, on over 3,500 distinct operating assets. Next slide. Handheld devices and augmented reality capabilities will leverage the 3D functional capability of the digital twin to validate operations and establish preventative maintenance requirements. There are many unique design features of this facility, including the ability to incorporate future planned geothermal capacity. Everything from a central plant perspective is integrated to include up to 3,000 tons. Next slide. And next slide. And next slide. This picture was taken on the day the steam blows to clean out the steam piping was occurring, and you can see the plumes in the background there. This was just about I don't know, a month before the final commissioning activities were taking place in the central plant. Next slide. Overall, this was a stellar project that I was privileged to be involved with. The vision and goals set back in 2016 were achieved due to amazing efforts of so many people working together to turn an idea into an unbelievable end product. I could use my entire allotted time saying thanks to those people. Likewise, there are many innovative aspects of this project that's left untouched with this presentation, and I'm sure those discussions will come at some future date. Thank you for your time. Next slide.
Thank you very much, Jeff. And I think we're going to get a lot of important questions based on the slides so far. So hopefully we get a more chance to talk about this great project. I'd like to then introduce our next speaker right quick here. The next person is going to be from Celanese Corporation, David Reid, who is our Senior Manager for Global Energy and Productivity. Celanese won a Better Practice Award this year for its employee engagement and education initiative called the Energy Sparks. So David, feel free.
All right, thanks, Bruce. Before I get started, I'd like to thank Department of Energy Better Plants program for recognizing us with this award. It's a really great recognition for our energy program and the energy teams that put this together. Next slide, please. For a successful energy program, those technical solutions to energy reduction are essential and really drive the energy improvements that we're all looking for. And many of the projects that you'll see today fit into that technical arena. But when operations teams that operate these projects and our plants lack the knowledge of the energy systems and the equipment, sometimes even the best energy and technical project can underachieve. But with more knowledge and understanding, the 24/7 teams, the operations teams can better operate, better troubleshoot, and resolve the energy issues faster and more effectively, allowing some of these projects to really hit their marks. So the Energy Sparks are a simple tool to increase that knowledge and understanding at the shift team level in a manufacturing plant. Next slide, please. So unfortunately, the people side of an energy program is often overlooked aspect of a long-term successful energy program. Engaging and getting commitment from those employees to get involved and participate is really essential. And I think that most people want to contribute, but sometimes they feel like they don't have enough information or enough knowledge to take part, so they don't participate. And then, like I mentioned before, some of the best energy projects and equipment that we put in can underperform through things like misoperation or just lack of knowledge on how the system's supposed to work. So through those misunderstandings or knowledge gaps, the system sometimes can be operated with things like incorrect set points, inefficient lineup of equipment, or sometimes even in manual mode that bypass the automation that we put in. I think we've all seen this in our plants, I'm sure. When energy people in the plants don't have that knowledge of how basic equipment works, or the knowledge to recognize it when it's faulty or in need of repair, sometimes they can fail to identify and correct the problem. And also, they can become complacent to inefficient operations. So also, when our teams don't know the dollar value, the magnitude of the energy losses, they don't realize the magnitude of what can seem like an insignificant issue, like a steam or a compressed air leak. Next slide, please. So what are Energy Sparks? So Energy Sparks are a tool we developed in Celanese to give our operations teams who are running our plants that knowledge that they need, enabling them to have a stronger understanding of energy as it relates to their jobs and what they do in the manufacturing plant. We picked topics that made sense for our plants. The goal is to share that knowledge and spark conversation, get action in the operations teams, and also generate some new ideas around energy efficiency and cost. So using some resources like Department of Energy tip sheets, the Energy Sparks are a simple and quick 2-minute fact sharing and conversation starter in a simple did you know format. They cover a wide range of topics, again, with that manufacturing mindset, including things like steam traps, compressed air, insulation, and pumping systems, things that our operators see every day. Now, the Energy Sparks can be shared at shift toolbox meetings at the beginning of their shifts, or also can be displayed on bulletin boards, electronic bulletin boards across the plants. Now, our shift supervisors and Celanese are always looking for topics to cover with their teams to generate engagement for whatever topic. And Energy Sparks give them that tool to get their team thinking and motivated about saving energy. Next slide, please. So the Sparks are really only a part of an overall energy management strategy, and they contribute indirectly to energy reduction by driving engagement to make that difference. But that difference is, in the end, what results in the improved energy efficiency, use, and cost. So one example of how Energy Sparks made that difference, at one of our plants, an Energy Spark on steam traps was shared with the operations shifts team. And the Energy Spark talked about how to detect a failed trap and shared with the shift operators at the toolbox meetings. Now, the site already had a maintenance program in place and annual inspections of their steam trap that was done by an external company, but the operators, following up on what they learned, suggested to do some further checks. Now, only 2 weeks after the external steam trap inspections were done, an operator who was doing his own checks found a critical broken steam trap and was able to get it repaired, almost immediately, saving about $7,000. Now, that may not seem like a lot of money, but these small improvements add up, and most importantly, they engage the operators with a result that they feel like they contributed to. So this is only one example of how Energy Sparks initiated conversation and action at the shift team level. Next slide, please. So currently we have 16 Energy Sparks that are available in English and Spanish. And our goal is to do two things. One is translate them into other language to ensure we connect with the teams covering the footprint right across Celanese, and also to continue to expand the number with new topics that relate to, again, to our operation teams. Now, a couple of things that are really important, I think, that Energy Sparks can be adapted to any subject in the sustainability space, including things like water and waste, as well as any kind of safety and environmental subject. And also, I think this is really important as employees become more engaged in energy reduction at work. this mindset carries over to their home and community life as well. And this tool, you know, for other companies, it can be easily adapted to any company who are, like us, are trying to engage employees in energy and sustainability efforts. Companies can develop sparks that are relevant and specific to their business, ensuring that meaningful topics are covered that connect with their teams. So again, thank you to the Better Plants program for the recognition, and thank you everyone on the call for your attention.
Great. Well, thank you very much, Daniel or David. That was a great presentation and right on time. I'll go right now to the next speaker. We have with us today Alex Zhang from Lineage Logistics. Alex is a senior systems engineer on the data science team. And this year, Lineage won a project award for an innovative blast freezer design and controls optimization project. So I'm really looking forward to this. Alexander, go ahead when you're ready.
Great, thank you. Good morning, everyone, and thanks for attending. And thanks to the DOE as well. It's an honor to be presenting here today. So I'd like to share how Lineage has been improving its blast freezing process. It's been an extensive and long journey and still ongoing. So let's dive right into it. Next slide, please. Next slide. So real quick, what is Lineage? Lineage is, we own and operate a bunch of cold storage warehouses, like the one pictured right here. And it's pretty self-explanatory. We store frozen food and we're a critical step in the global food supply chain. Next slide, please. So we have a global presence. We're the largest international refrigerated warehousing company now with over 200 facilities worldwide, or almost 200 facilities, I think. And in the US, around 30% of all frozen food will touch our warehouses at some point. But these warehouses use a lot of energy as well, so we have a large energy footprint. So, and then the megawatts for some of these facilities. Next slide, please. So real quick, what is blast freezing? Usually we just store frozen food where the food is already frozen and people give it to us and then we keep it there for a duration before sending it off to like the end user. But in the blast freezing process, we take food that is still at ambient temperatures, like freshly produced meat packed product, things like that, and we rapidly chill it in a room we call a blast cell, which is at -20 or lower Fahrenheit. And then we cool that as quick as possible to maintain this food integrity, food quality, and food safety so that it can go into our freezer before we ship it out to the end users, supermarkets, etc., restaurants. Next slide, please. So here's an example of blast product where at a certain facility we have in California, it's overnight, they might just see this show up. These are just a bunch of 2,000-pound pallets of strawberry drums. And so the customer will ask us, hey, we have these truckloads of these drums you see here. Can you quickly blast freeze it all for us? So next slide, please. So we have to put them into what we call a blast freezer, which is a room using the refrigeration system that we have that blows out really cold air from these evaporators, again, -20 Fahrenheit or lower, and cycles it through this racking space where we'll put all the different products. So in this case, it would be all these strawberry drums, like the example before. Next slide, please. So what makes a good blast cell? There's two main components. You need the blast cell to be cold enough. So that's part one. The temperature and refrigeration capacity needs to be appropriate. And then two, you need good airflow. So I think the best analogy here is it's kind of like a water hose. You need enough water pressure and you need good distribution so you can like water effectively. Next slide, please. And please play this video. So this is just a quick video of how a good airflow should look like when it's going through the like one pallet. In this case, these are just boxes. So you want the air to be able to touch as much surface area as possible as it's moving through each of these pallets. Next slide, please. So we 3D modeled the existing design that we have to see how the airflow distribution was within the cell. And these are the results that we got. So red is fast and blue is slow. And you can see what we're really aiming for is equal distribution of airflow, and we're not getting it here. So next slide, please. So we took a FLIR imager as well to see if the real world results would match our simulation results. And we got what we kind of expected, where there's like a differential gradient in the freeze rate of the pallets when we load one load. And that's not good because each of these pallet loads are loaded in one batch. So we have to freeze and remove everything at the same time. Next slide, please. So we basically ran an R&D project where we tunnelized the design. The easiest way to control airflow is just to blow through a tunnel, point A to point B. So we modularized these tunnels. We put these louvers on the back to control the airspeed, and that was the idea behind this design. Next slide, please. And so here's the simulation results of the tunnel design, where you can see the air is being drawn through equally through each tunnel, and the air flow is controlled by the louvers on the backside of each tunnel. Next slide. And we built it in real life. So pictures in real life, it matches the model that we made. Next slide. And we tested it out using temperature sensors where we put in each of the pallets to get the freeze curves. So these are the results. We managed to cut down the average freeze time from 75 hours to 50 hours. So it's a good result. Next slide. We wanted to come up with a newer design that uses less moving parts. And so you see it here where we call it the guided airflow design. We're just using more like air guiders to control the airflow. Next slide. Here again, you can see the air guiders. The idea is just to use these kind of like turning vanes to control the airflow instead of using louvers. Next slide. And we try to make this modularized as well. Next slide. So here you can see the comparison between one of the existing designs on the left and the new design on the right. And after a couple of seconds, you can see how we get good temperature distribution on the new design, but on the old design, you have this disparity between the pallets that are on the top and the pallets that are on the bottom. Next slide. And you can see that here as well with the airflow. Next slide. So we built it in real life. Next slide. And then you can see it here as well. I LiDAR scanned it. So it looks pretty much as you would expect. Next slide. And I just want to dive into the results here where we cut down the freeze time to 35 hours from a 72-hour freeze at this facility. Next slide. And if you look at the projections, we are basically able to double the throughput with a 20% energy efficiency increase. Next slide. So we're still working on new changes. We want working on bidirectional airflow and things like that. So it's still a work in progress. Next slide. And then the last two slides is we patented this design and we're still working on future improvements.
So I think we're just past the 6-minute mark, Alexander. Thank you very much.
Yep, thank you.
Yeah, really good, really impressive, and we're glad that y'all applied and got the award this year. I'll go ahead and introduce our next speaker. That is going to be from General Motors, Ms. Kate Peterson. Kate is the Energy and Carbon Optimization Engineer, and this year General Motors won a Better Practice Award for their project tracking and interplant communications. So I'll let Kate take it away.
Thank you, Bruce. And Cliff, you can go to my title slide. Hello, everyone. So I'm with General Motors Sustainable Workplaces in the Energy Carbon Optimization Group. And first of all, we want to thank DOE for selecting us for the Better Practices Award. It's an honor to talk here. And today I'll be focusing on the General Motors project roadmap. You can switch to the next slide. So this roadmap was created to address our GM sustainability goals. In particular, one of our goals is to reduce our 2010 carbon emissions by 31% by 2030. And this goal is largely achievable with energy efficiency projects, which I'll talk about today, and our renewable energy strategy. So energy efficiency projects are largely identified by third parties, by people in the plant, and by energy treasure hunts. And energy treasure hunts are really just 3-day deep dives into the energy and water procedures of plant production, during plant production and non-production times. And then on the third day, you can see there's a picture on the right. It shows a presentation to plant leadership, which presents our findings and then potential projects that the plant can pursue. So we've done a lot of these energy treasure hunts, which is great because it means we've amassed a lot of efficiency projects and water efficiency projects. The only downside to that, and actually Cliff, if you go to the next slide. Thank you. The only downside to that is we've really never thought to try to share all of the plant projects with each of the plants. So pursued projects were generally tracked as a part of the plant's energy performance measures. However, suggested projects like ideas from the energy treasure hunts really just kind of remained in the energy treasure hunt folder for that particular plant. So in general, it was kind of kept like out of sight, out of mind for a while. And then any completed projects were not really compiled for other plants to view. Instead, project information was generally delivered like through the grapevine. If one plant manager knew another plant manager, for example. You can go to the next slide. So we realized we needed a tool that would track both past and current plant projects. And we wanted this tool to be live so that it would update with the most current plant project information. We also wanted this plant project information to be available to all plants. So we wanted to share both past projects that were created maybe in like 2016, all the way up through the current projects that plants are working on today with all of the GM facilities. And we wanted this information to include the granular details, like the cost to implement, the energy savings that they expect, the energy savings that they actually found, et cetera. And we wanted this tool to be really easy to use. We knew that if it had some sort of interface that was a challenge for plant managers to learn, they probably wouldn't use it. So we kind of stuck to the Excel format to really showcase this tool. And we also wanted to show really concise and easy to understand project information in visuals that the plant energy managers could present to plant leadership, for example, if they were trying to suggest some sort of energy or water project. Next slide. Thank you. So we came up with the project implementation and identification roadmap, which is a mouthful, so we just say roadmap. And on the bottom right, there's a screenshot of one tab of the tool. And as you can see, I mean, you can't see because it's all blurred out, but we've listed all of the projects from all of the plants. And then towards the top, you can see that plant managers can go into their specific roadmap and actually filter down to see the specific equipment or system that they're interested in, and look at energy opportunities that any other plant has pursued in the past, I think 4 years is what we've been tracking. And as I said, this is live, and we were able to do that using Power BI. And if you guys have any questions on that, you can feel free to submit the questions to Slido, and I can address that at the end if there's time. So you can go to the next slide. So while this does improve plant-to-plant collaboration, it also really improves project tracking within the plant, like for the plant energy manager. So it tracks plant projects from like ideas that were suggested in treasure hunts, like you can see is selected in the screenshot there, all the way through completed projects. And we ask plants to input information like what kind of budget it came from, their actual energy savings and their estimated energy savings that were estimated when this was an idea, and then all the way down to like the actual cost of the project so that we can actually know and be better estimate for next projects that we come up with. All of these details also allow for project duplication and benchmarking for other plants to pursue. If you go to the next slide. So this project roadmap could always be improved, and due to COVID-19, we weren't exactly able to get any feedback up until this point, but we're excited as plants are starting up again to receive that feedback. We're also excited to expand globally to all of GM manufacturing sites, because as of right now, it's really only been broadcast in the United States. And then we'd also love to collaborate with industry partners. Thank you. I think that's all the time that I have for this, but it's been a great privilege.
Thank you very much, Kate. You're actually a couple seconds early, so thank you very much for a great presentation. Our next speaker is Mr. Nathan Onchuck from Ozinga Brothers. And Ozinga Brothers, I'll just as an aside, is technically more of a construction company, although they do have industrial scale energy using applications. And this shows how we've been able to expand beyond the mainstream manufacturing, and we're still growing, so we can continue working with companies like this. Nathan is the Energy and Sustainability Manager for Ozinga. They won a project award this year for their data logging to maximize energy efficiency project, and they also have a great compressed air example. So Nathan, take it away.
Thanks, Bruce. You could go ahead to the next slide. And again, we're really appreciative of the help that we've gotten with the with this project from the DOE. You'll see shortly that their loan program, their equipment loan program, actually ended up being the catalyst behind all of this. But I wanted to start with this map that shows all of our locations in the all of our ready mix concrete locations. And I think there's a unique challenge to our industry that each dot you see on here, the entire plant really has a motor load less than kind of a single piece of equipment at some of the other major manufacturers that are recognized by the program today. So anything that we wanted to do to get real-time data from these plants on their energy usage had to be, I guess, cost-effective sounds a lot better than cheap, but I think cheap gets the point across better. So if we go to the next slide, we already had a good idea of what some of our significant energy users were going to be, and it was the air compressor that ran the plant, the feed belts that moved all of the raw materials into the plant, the central mixers at plants that have those, dust collection, and then we expected the remainder to be made up by just small horsepower pumps and blowers. For the most part, we don't have major cooling loads or anything like that. So overall, it's a relatively simple list of equipment. And if we go to the next slide, we ended up coming up with the equipment loan program, partially because I have friends in IT, so we had initially started looking at what it would take to connect everything, and let's just get real-time data for every piece of equipment in the plant. And kind of quickly found out that that would cost more than we spend in energy, so it wasn't going to be possible to recover those costs. So we started small and worked with both our TAM, Christina, and Daryl, who helps run the DOE's equipment loan program, to just try out different data loggers. And we found that using just CT clamps and pressure transducers, we were able to get a surprising amount of information off of our plant equipment. So if we go to the next slide. One of the first projects that we had done was just monitoring one of our rotary screw air compressors. And the compressor was set up initially to maintain just a 10 PSI pressure band, and it would run in a load idle cycle. So the motor was turning the entire time that the plant was open. And we were able to make these charts that you see just showing whether the motor was loaded, idling, or shut down completely. So you can see the first chart shows that the compressor was running all day long. And when we really dug into the compressor manual, we found that it actually had some different operating modes settings. And one of them was called this vario mode, that the compressor would actually track its own motor starts and motor temperatures to decide whether or not it could idle or just shut down completely. And then in order to give it more time to be shut off between loads, our plants are very batch focused. We're either loading a truck and using air, or we're waiting for the next truck to pull under and we're not using any. So we reduced the lower pressure set point by 15 PSI to now give the compressor 25 pounds of storage between cycles, and then put it into this vario mode. And what we saw was a 68% reduction in the compressor's runtime throughout the day, and a 65% reduction in the compressor's energy intensity. And the next slide shows how we were able to take that same data, although this chart is actually from a different compressor, and model how much air we're using throughout the day. So we used a 3-minute average, that's the red line, as that lines up pretty well with what our batching timing takes. So we actually found that this compressor was undersized for the plant when we were really busy, and it'll be moving to a new plant that's smaller, has lower air demand, and it'll be getting replaced by 2 smaller machines that we were able to size based off of this data. And then the next slide shows one of the other tests we did just on conveyors. So this is from a feed belt, and we realized that the compressor or the conveyor runs empty almost the entire time that it's running, just because it's on manual controls. So we're going to be installing a soft starter on this conveyor and tying it into our batch sequence. So it starts and stops automatically as it's needed. And we'll hopefully see that utilization ratio go up after the project. And the next slide. So that knocks out 2 of our biggest energy users. And our hope is with this data, we're going to be able to prove out these projects and start to build a repeatable project that we can take to all the other locations, and hopefully start to really scale some of these different energy savings projects. And that is all I have. So thank you guys.
Great. Well, thank you very much, Nathan. That was a great presentation. I'll jump now to our next speaker. This is Robin Davies from Imperys Carbonates North America. Robin is the energy engineer for Imperys, and they won a Better Practice Award this year for their dust collection system optimization and standardization across the enterprise. So Robin, go ahead, please.
Thank you. We're really excited to win this award, and I'm very excited to be sitting here talking to you guys today. Next slide, please. So yes, our award or our project that we took over was the dust collectors within our plant. A little bit of background on Imperys. Next slide, please. Imperys is a mining and mineral resource company, worldwide global company. We mine out of the ground around 30 minerals. And what do we like to tell people is we take dirt and rocks and we make it a usable product. Some of us never really grew up. We still like playing in the dirt. So one of the challenges we have with taking this dirt and all these rocks are it generates a lot of dust. We end up with multiple types of processes that require dust collectors, and we have this all across the sites worldwide, and we noticed that no 2 sites handled it exactly the same. If you'll jump to the next slide. We have electricity is our second biggest energy consumer, and one of the biggest uses of our electricity is compressed air. And most of our compressed air is used in these dust collectors. Most of our dust collectors throughout the plants, they're there for environmental compliance, to stick with maybe EPA or an EPD compliance, but some are also used for conveying purposes or process purposes. When we realized that multiple sites across the US were managing it differently and had different projects going on and different ways to save energy, and some weren't saving energy, we realized there was a big opportunity here. And so we sat down as a group, and we had the asset management group from our corporate group, as well as our global energy teams, basically sat down and said, this is going to be our first area. And we like it because it covers EHS, it covers energy, it covers plant reliability. It basically covers the whole spectrum of the business, and this is going to really help us be a better company and be more sustainable. Next slide, please. So looking at just North America, we have 40 plants in North America. Within these plants, there's over 500 dust collectors. Again, most of them had different kind of ways of handling this. So what we did was we reached out and we took all the leaders from those plants and said, what are you doing with your dust collectors? How are you managing them? Most had some initiatives ongoing that we were able to bring in. Some said, we just make sure they're in operation and we forget about them. So we kind of rolled all this up and put it all into one package of what's everybody's doing and what's the best way forward for the company. We then went beyond that and we reviewed industry standards. We talked to many of our suppliers, anything out there from other companies, other best practices, and we reviewed it and compiled it all into one document, which is, you see the cover in the picture here. But basically, this is going to be the reference form that everybody's going to go to when they said, I need to work on a dust collector. I want to make improvements in my dust collection system. And this is full encompassing from the very beginning all the way through the end of the process with a dust collector. Again, we covered recommendations in there for EHS, the energy, production, maintenance, the whole gambit that would affect the company. And we released this document on March 18th. So it's just now getting rolled out. I'm going to talk about a few of the initiatives we've already had ongoing that it went into this best practice. But now everybody's a part of it, and we're starting to roll this out on a lot of the other sites. And we've gotten good feedback too. A lot of the sites have already taken it and run with it and said, we've been needing something like this and we want to implement as fast as possible. Next slide. So just kind of talking about some of the things that we included in this best practice. One of the first things we found was just lowering the plant air pressure. A lot of our plants kind of went through the years on, if 80 PSI is good, 90 is better, and 100 is even better than that. And we realized that we were just over generating compressed air for no reason other than we said it was going to be better. So some of our facilities have been able to reduce just overall plant header pressure, which gives us a very easy, quick win on the energy aspect. We went out and we found new technologies as well, particularly with these pulse valves. And the ones we've kind of started using are from a company called Mac pulse valves. It's just a new way of handling this. The old system was an old rubber diaphragm that had been around since the 1960s. It does work, but of course technology has come a long way. So using these new technologies is helping us in terms of reducing the compressed air used at our dust collectors. Water filtration or water separation before the dust. You can imagine, a fine dust, a fine dirt dust, and water does not mix very well. So we want to make sure we get all that water out before it reaches our dust collectors. We've come across a couple companies, Tsunami's one that we're kind of looking for, but there's multiples out there. And along the lines of EHS and kind of how to not only save energy, but get kind of the buy-in and how to apply it across the board, we started looking at things like differential pressure on these dust collectors. This has been a big help. The environmental groups, EHS, have loved this because it helps them monitor their compliance to some permitting as well as troubleshooting. When we do have something, we have to go back in and look. So that's been a big help within the plant, just simply some automation and sensors within the plant. And then also we're looking at, have been putting in a pulse on demand system. And basically a lot of our plants were originally working under continuous pulsing, which basically means it's pulsing on its set schedule continuously, 24 hours a day, 7 days a week, 365 days a year, unless we flip the off switch. So a lot of our plants, the new way of going about technology is we can actually put this on demand, and it's based off the differential pressure. So as the differential pressure climbs, it'll actually turn the pulses on. When it hits a certain differential pressure point, it'll shut the pulses off. So that, again, yep.
We're right at the 6-minute mark, so if you can wrap up, please, I appreciate it.
Oh, yep, sorry. So implemented the pulse on demand. Next slide, and I'll just hit the highlights. So I have some overview here about the Sandersville calcine plant. I think we've covered it with a lot of the new technologies, but essentially what we've seen is we have the potential of 14 gigawatts possibly reduced, as well as 6,700 metric tons of CO2. So it's a big impact for Imperys North America. And then on top of that, we're rolling it out worldwide. Thank you.
Great. Thank you very much. I'll go ahead and introduce our next speaker from PepsiCo. Michael Waitek is the engineer on the corporate sustainability team. This year, they won a Better Project Award for a cogeneration project at one of their Gatorade plants in Indiana. So Mike, go ahead.
Yeah, good morning, everybody. Thanks to the Department of Energy and the Better Projects team for choosing our project for this recognition. It's really nice to be part of a project that can be recognized nationally. Go ahead and start on the first slide, please. Again, I'm going to present the Indianapolis Gatorade cogeneration system, which is combined heat power. The cogen project at the Indianapolis facility was an important project for Gatorade and PepsiCo, and I'm excited to present the multiple benefits that the project provides. The project was designed to lower electricity costs and save money, as well as reduce our greenhouse gas emissions, which is part of PepsiCo's Winning with Purpose initiative. The PepsiCo Winning with Purpose initiative is an initiative to reduce environmental impact of keeping our consumers hydrated and fed by making our products with the least amount of fuel, electricity, water, and plastic as possible. So as I mentioned, this one reduces our electricity use from the traditional utility power plants and really helps with greenhouse gas emissions. We had a couple partners with this project, both McAllister Power Systems and Thermal Energy Incorporated. McAllister is the manufacturer of the engines, and I'm sorry, Caterpillar are the manufacturer of the generators and engines that produce the electricity. And Thermal Energy Incorporated is helped us with the design and installation of the heat recovery system that I'll get into as well. It was a $6 million capital project that included the generators, the heat recovery system, and installation for all that. That provided about $1.45 million of annual utility savings in both fuel and electricity. And that resulted in about $1 million a year net savings with the maintenance contract that we purchased to keep our generators and engines running in tip-top shape. The really cool part about the project is this resulted in a 35% reduction in greenhouse gas emissions for the plant. And with this particular plant being a large plant in PepsiCo, it represents about 6% of PepsiCo's 2030 goal to reduce greenhouse gas emissions. And we fired this system up in January 1st of 2019 when the plant started up. A little bit of information about the project. It consists of 3 1,700 horsepower natural gas engines that turn 1.2 megawatt generators, resulting in 3.6 megawatts of total output. That provides about 90% of our plant's electricity use when it's running at full load. And it also reduces our peak demand, which a lot of those in the industry know that peak demand can result in some really high electricity costs. We really got this project in a good spot by utilizing heat recovery. So all the heat, or I would say a lot of the heat that's generated by the engines from both the cooling system and exhaust are utilized for the processing of Gatorade. I'll get into a little bit more of that here shortly. It reduces the load on our natural gas boilers that are needed for processing Gatorade, and of course reduces our overall utility costs. This system efficiency approaches 85% when it's running at its best. And that's really great because the normal utility efficiency for a coal-fired plant here in Indiana is about 35%. Next slide, please. Get into some of the details. The generators utilize a pretty specific or sophisticated control system to produce electricity only based on the plant load. Our generators are not intended to backfeed the grid here. It wasn't part of our project based on financials. So the generators are designed to analyze our plant load and only run to produce enough electricity to satisfy that load. They can run down to about 50% loaded. So basically they run from 600 kW to 1200 kW each. And then get into the heat recovery. A Gatorade is a thermally processed product. So it provides a very large heat sink to utilize for engine cooling. So the majority of the energy that's required to cool the engines is provided by transferring heat to our Gatorade product across multiple production lines. We can raise the temperature of our product by nearly 40 degrees on some of our lines, depending on the flow rate, which is really good for more or less free energy use for cooling. Not only in the cooling of the engines, but we also use the exhaust that's created by the 3 engines to make steam. So the 700-degree exhaust is to make steam with a natural gas boiler that we converted for additional heat needed for processing. And you can see some of the graphics there that kind of show how our heat recovery system works and how the generators are controlled. Next slide, please. Just wanted to show a few pictures of the project. The project did provide funding for a new building that all 3 generators are housed in. On the top left there, you can see the intake fans for building ventilation. And then on the other side of the building is where the intake is for engine air. The project does have its own control room, where you can see in the middle there, each generator has its own touchscreen controls and operate individually or in tandem to meet plant level. There on the top right, you can see some of the two of the three generators that are in that room. The generators are very large, so it's hard to get a picture of all three of them together, but you can see the size of the generators in that room there. The bottom left shows the boiler, the natural gas boiler that we converted to what we call a heat recovery steam generator. There on the left-hand side, you can see the ductwork coming in from the engine exhaust header, and that replaced the burner of the boiler, and we use the heat from the exhaust to create steam. And then on the bottom
At the
right,
6-minute mark.
on the bottom right there, there's the heat recovery pumps and heat exchangers that are responsible for circulating all the cooling water that cools the engine. And that's it for me.
Great. Thank you very much, Mike. That's a great project. I'll go ahead and introduce our next speaker. Before I do that, I'm going to say we're probably not going to have time to address the questions that we're getting, but we are going to likely send them to the individual panelists, and they'll be able to follow up with all the people who submitted questions. Our next speaker now is Bert Hill from Volvo Group North America. Bert is in charge of health, safety, and environment for Volvo Group. This year, they won a Better Practice Award for their landfill-free diversion efforts. So Bert, go ahead.
Okay, thank you very much, Bruce. And I'd like to thank the DOE for this award, as well as all the other cooperation over the last 10 some odd years. Next slide. As Bruce mentioned, the name of this project is a landfill-free directive, which we developed at a corporate level, and then also a certification process for our plants to achieve that certification. Next slide, please. So a couple of things about the Volvo Group. We are about 100,000 people. We have production in 18 countries and sell our products on more than 180 markets. Next slide, please. So our stated mission is driving prosperity through transport solutions. And when we say prosperity, we mean sustainable prosperity, because prosperity by itself is no good to anyone. So we want that to be sustainable and benefit mankind. And then transport solutions, we're moving from selling products to more selling solutions. So an example of that is a pilot project we got running in Norway, where we have a piece of construction equipment that works kind of like a Roomba vacuum cleaner, but it hauls materials from one location to another all day long. When it gets tired, it'll go hook itself up to the charger and get charged up and then go back to work. If it starts hurting, it'll call up the mechanic and say, my bucket hurts, can you come take a look at it? And the mechanic will come out and take a look. So we're moving into more solutions like that. Next slide, please. So the principle we've followed for all of our waste reduction activities, it's called the waste hierarchy. Some of you may have seen this before. But the best thing you can do in waste management is to prevent the waste to begin with. And that is followed by this big section with reducing, reusing, and recycling, which you've probably seen around. And the fraction we can't take care of with those methods, then we send to energy recovery. And what we try to prevent at all costs is incinerating something without getting any energy from it or sending it to landfill. Next slide, please. So I'll run through some of the initiatives that we've used according to this principle of the waste hierarchy. We've done studies where we've looked at the amount and types of packaging that are coming from our suppliers with the components. So we get an idea of what they're sending us, how much they're sending us, and then working directly with the suppliers to reduce that amount of packaging. And one thing our logistics group has done in this end is to create a system with returnable and reusable Volvo emballage. You'll see that in the photo at the bottom there. So we create a loop there with our suppliers where they supply the components in this emballage and we send it back to them, and we prevent one-time use packaging. And then another big component of this are plant level initiatives of things you need to set up to create this reduction, reuse, and recycling program. And that's things like the implementing the infrastructure, putting in sign, training employees. And then we also here in the U.S., we're a little bit worried about our liability from sending waste to landfill, because many Superfund sites are landfills, and we didn't want to get caught up in that. So we did a benchmarking project with 9 other major U.S. corporations to see what they were doing to reduce their liability. And what came out of that project was that most of them are using a national account with a single waste vendor. That way they can cooperate with this vendor to try to reduce their waste and also limit the number of facilities where the waste is going. So we've done that to try to reduce that liability. And then the project I'll be spending a little more time on, the landfill-free waste directive and the certification process. Next slide, please. So the certification process comprises these 4 elements that you see here. And the first thing we want to see from a site is that they've documented and mapped all of their different types of waste, because that's where you start. You need to know what you have, how much of it you have, before you can map out what to do with it. And then we want to see a program that covers this big portion of the waste hierarchy of the reduction, reuse, and recycle. And we want to see that that's been in place for at least 12 months. So we look at records going back 12 months. And then we also want to make sure that not more than 1% is going to landfill. Next slide, please. So to date, we've had 4 manufacturing plants that have achieved the certification. We have our Volvo truck plant in New River Valley, remanufacturing in Middletown, Pennsylvania, our Mack truck plant in Lehigh Valley, Pennsylvania, and our Volvo construction equipment plant in Shippensburg. We have 3 more online that are going through this 12-month evaluation period. And as a result of these initiatives I've shown you, last year, only 6% of the waste from our facilities was landfill. 78% of our waste from our operations was recycled. And just like to quickly name a couple of our businesses that complete this loop in the circular economy. Our remanufacturing operations take engines and other powertrain components and remanufacture those to original specifications. So I've seen serial numbers on engine blocks that go back decades. So rather than using new raw materials, energy, and chemicals, we try to remanufacture these parts so they get several lives. And then also our Dex heavy duty parts takes in complete vehicles and completely disassembles those. And they'll sell parts like hoods, entire cabs, wheels, seats, you name it, on the aftermarket. So those don't have.
Thanks, Bert. We're at the 6-minute mark just now.
Okay, thank you, Bruce.
Thank you. I'll introduce our next speaker. We have with us today from ThyssenKrupp Elevator, Daniel Downen and John Keller. Daniel is a facility engineer and John Keller is a manufacturing engineer. ThyssenKrupp won a Better Project Award for their innovative process heating / furnace optimization project. So Daniel and John, go ahead.
All right. All right, let's go to the next slide. First, I want to thank the DOE for the honor to be here to speak to you guys and to represent ThyssenKrupp Elevator on this project. Next slide. I want to tell you a little bit about ThyssenKrupp Elevator. We're located in Middleton, Tennessee. It's the only plant ThyssenKrupp has in the United States. We're a worldwide leader in elevator manufacturing. Also, our factory that we currently have was established in 1969. We have about 700,000 square feet of manufacturing space. Of course, the rest will be office space. We employ about 1,100 dedicated, hardworking employees here. We create an elevator from start to finish inside our 4 walls. Our sister company, Energy Management, is very important to them, and that's kind of how we got started with this. Some of the accreditations we have received in 2019, we received ISO 50001 certification. Also in 2015, we're LEED Gold certified. Also, we're ISO 9001 and also 14001. If you look to the right there, One World Trade Center is one of the projects we've recently done that we thought everyone would be familiar with. We're proud to be a part of that as well. Next slide. So basically in our, we have two paint lines here in our facility. One is the structural parts. Those are the parts that go under the elevator and the elevator shaft. And we also have one for our architectural parts, or basically the parts you see when you step inside the elevator. As part of the 50001 certification, we realized our structural ovens were significant energy users. We use a little over a third of our natural gas is used in our paint ovens. So we decided then it was somewhere we needed to start to try to save some energy there. Our ovens run somewhere, we run 2 shifts a day, depending on overtime, we're 9 to 10 hour shifts. So we're spending 20 hours a day a lot of the time. One thing we had to try to get buy-in as far as our manufacturing side, because our parts are so critical and quality is important to us, we didn't want to save energy and then mess up and make a bad product. So we had to try to get buy-in on that, and that was the part that John and I tried to push. Next slide, please. In 2018, we had an IEC audit done, basically an energy treasure hunt, so to speak. University of Memphis sent graduate engineering students down here, and we put data loggers all over the facility, got measurements of our ovens, and also we come up with the idea of installing insulation in our ovens. Our oven is multiple decades old, and so there wasn't a whole lot of data on that. But we knew by shooting it with temperature guns that there was a lot of heat loss we were having as a result of that. We decided to add about 6 inches of insulation to the tops of our oven. As a result of that, we use data loggers, as I said earlier. We also did an IEC. We showed some great things there as well, but we also had our TAM rep come in 2019 and do another treasure hunt. With the help of him, we were able to get some baseline numbers to start with using the DOE measure tool. We constructed a model of that, see what our heat loss was through that. Next slide, please. I'm going to turn it over to John Keller, our manufacturing engineer. John?
All right, I'll give you a little more detail. As Daniel mentioned, we recognized our oven was a significant user. So we started, the journey had to start with a beginning point. So we gathered data and used a measure tool to build our energy balance model. We used this data to identify what to do. The low-hanging fruit for us was oven installation. We used a tool called Rock Assist that Rockwool made to input the skin temperature or the heat loss, the ambient temperature, the airflow by it to help calculate the maximum thickness, or it gave us the most payback. We also it calculated 6 inches was optimal for us, but we used 3 inches because it allowed us to overlap our joints to have two separate layers, and it sealed a little better. Throughout this, we used the energy balance model that using the measure tool to confirm our savings. The data also showed that we had an excess of exhaust leaving the oven. So we had 2 exhaust stacks running during the purge cycle, and then it was designed for one to cut off after the purge. We found that sometime in the 2 decades it had been in operation, that had been disabled, and both exhausts ran the whole time. So we worked through the code requirements and disabled one after purge, and to still meet the code and required air changes, but not put excess heat straight out to the atmosphere. We also added a vestibule to the exit ends of the oven to help provide a natural convection roll to help create a natural air seal. And through doing this, we've noticed the data showed that we had a significant reduction in the firing rate from not having to overcome all the heat loss. We also noticed that the oven came up to full temperature in about 45 minutes. So we reduced that tremendously. We used to take over 2.5 hours for the oven to normalize and get up to temperature before the burner started to modulate. And now we're doing that in 45 minutes. So we reduced how early we start the oven. So it's just hours that we're not running the oven per day. I'm sorry, go to the next slide, please. We reduced our firing rate from 5.2 million BTU to 4.2. Huge reduction for us. I mentioned we start to light the oven later. Collectively, it resulted in a 34% reduction in fuel use. Next slide, please.
John, we're right at the minute mark.
Okay. To make sure we're getting quality cure schedule on our paint, we run a data pack through to make sure we're still getting the correct temperatures. Next slide. So the results were, as mentioned, a 34% reduction in fuel consumption and an annual savings of about $31,000 per year. Right, thank you.
Thank you very much, John. I'll go ahead and introduce our last speaker, and thank you all for staying a little extra for today. Marco Gonzalez from Waupaca Foundry Corporation. Marco is a corporate energy manager, and this year they won a project award for a cupola furnace optimization by reducing humidity in the blast air. So Marco, before you go ahead.
Well, thank you, Ruth, and we are really happy and honored to receive this award from the DOE, and that means a lot for us in our energy journey. And we really appreciate the Better Plans team and everybody here making this present. So let's start it. So we're going to talk about our cupola blast air dehumidification system. That's one of the projects we recently implemented at one of our locations, and is part of a large portfolio of projects we're doing to improve our melting process. So go to the next one, please. So who we are, Waupaca Foundry, a Hitachi Metals company. We are basically metal casters. We produce gray iron and ductile iron for different manufacturing sectors. Where basically we have a high penetration in the market in the US and globally. I'm pretty sure you may have some products at your house, in your car, that has been made in any of our plants. So keep in mind. So in the early 2000s, Waupaca started thinking about how can we become transformed into a more green process and a green looking towards a green foundry process. And we defined our sustainability goals early 2000 towards the 2020, where our last year right now, I'm thinking and adjusting our goals towards the 2030, 2050. Our energy program is basically, our energy goal matches the Better Plans program. We were one of the first companies to join what is now the Better Plans program, and we're proud of it. And we also became the first metal caster in the United States to earn the ISO 2001 certification. Next slide, please. The project we're going to talk about was implemented in our Plant 5 in Tell City, Indiana. That's one of our largest plants in the US, and we produce a lot of brake rotors and different parts for automobile and commercial truck. We employ about 1,000 people there, and in a footprint of 560,000 square feet. Next one. Next slide, please. Okay, so let's talk about the melting process. As a metal caster, basically we grab the scrap material and melt it to transform and cast the pieces we're gonna sell in the market. And Waupaca is considered one of the largest foundries in the world. We have a capacity of 10,000 tons per day we can melt. That, just to give an example, that's equivalent to the Eiffel Tower. So we can do that in one day. And 80% of that volume is melted using cupola furnaces at 7 locations. A cupola furnace, for those that are not familiar with the melting process, is basically a vertical steel shell. That's basically the brown column in the diagram shown. That is lined with a refractory brick. And then we start doing layers of steel scrap material and then coke, which is the fuel that provides the heat, but also provides carbon to the chemistry. So the coke is consuming air, which is introduced using a blast air fan. We're talking about volume of 17,000, 18,000 CFM of air and oxygen injection. That will give us the temperatures we need to melt the iron and also to get the chemistry we require. That produces a lot of heat and a lot of gases, and it's to be filtered and burned and eliminated before sending our emissions to the environment. So we keep our clean stack air emissions. And if you see basically the right part of the diagram, besides the brown column, is all the environmental control. That environmental control not only eliminate all the greenhouse emission gases, but also allowed us to recover a big part of the heat that we produce to melt the iron. And that way heat is usually implemented in other secondary applications, for example, building heating during the winters for Wisconsin plants. And that was the waste heat recovery represented one of our first efforts in recycling or reducing our environmental footprint. And we're proud to say that we have earned several awards on waste heat recovery. So cupola plants and all the melting cleaner represents about 70% of the total energy we use in our cupola plants. And that's basically why we're focusing on this project. So next one, please. So the problem was related to humidity impact on the cupola blast air. Injecting that huge volume of air into the cupola was causing that we basically during the summer, we see like kind of a seasonal effect, similar to what we see usually on an increase on electric demand, but that was affecting our melting efficiency. So during the summer, because of the high humidity that we're putting into the melting process, we saw an increase in coke usage and reduced combustion temperatures that were affecting our production. And there is basically the physics explanation about that is the oxygen reacting with the coke and producing more CO and it's stealing the heat from the system. But it's like a good example if you're trying to do a barbecue using charcoal during a rainy day versus a summer day. I mean, the rainy day will put humidity into your combustion process and will steal your heat. Okay, keep next one, please. So the solution was part of a large portfolio we're doing to increase our energy efficiency across our cupola processes. And this one is basically focusing on installing a dehumidifier. The dehumidifier is a desiccant wheel that we implemented in a partnership with a cupola manufacturer and the dehumidifier manufacturer that basically remove the humidity air from the blast air we're injecting and provides dry and air to the system, so the combustion process, so we increase our melting efficiency. The dehumidifier is a desiccant wheel basically that turns around that uses two main inputs, energy inputs. One is a heating system to dry and evaporate the water that is removing, and the other is a water cooling system to cool the air that is dry, but it's too hot to go into the blower. So we're proud to say that to reduce environmental impact even on this project and to maximize the energy savings, the energy required to regenerate the air, which is basically the heat we are using part of our waste heat recovery, and we tie this water cooling system to our cupola cooling system, so there was no additional load connected to the plant because of this system. Next one, please.
Hey, Marco, we are just past the 6-minute mark.
This is my last one. So basically, to summarize the benefits, there was a 3% cupola melting increase of this, and the benefit of it is now we see uniform performance of the cupola across all the year. We used to see in the summer on a very humid day how the efficiency drops, and now we can see our cupola performing like in a steady state. And that represents about 2.5% coke reduction the savings we reduce, which is equivalent to about 17,000 MMBTU or $335,000 in savings. That allowed us to reach a payback project in about 3.5, 3.8. And just to provide a reference, the water we have removed over that blast air is about 126,000 gallons of water, equivalent to about 21 trucks of water. So just to give you an idea how big is these savings and just removing water from the air and how is a huge impact for us. That's all, Bruce.
Thank you very much, Marco. And I have to thank everyone for staying a little extra. I know we went over time. Just a quick note that we are going to have a webinar series this summer, so we definitely invite you to attend those. We'd like to thank everyone for attending. And we also have some contact slides. So if you have any questions and you want to contact the speakers directly, feel free to contact them there. We will be posting these slides on the Solution Center next week, as I understand. So you'll be able to contact them that way as well. Yeah, I think that wraps up our presentation or our session for today. We look forward to seeing you at future sessions going on today and tomorrow. Thank you very much, everyone.
Yeah, thanks, Bruce.
Thanks, Bruce.